Hello, my name is Fatih Yıldırım. This is the turn project representation video of the ELE417 course Embedded System Design, and we will examine each MSP one by one. This MSP430 is responsible of reading moisture sensor YL69, encrypts it with AES algorithm and sends it to the transceiver. Main routine starts with the system clock port initializations, ADC configuration and NRF24 initialization. Transmission is done on the channel 100. Encrypted data is loaded to NRF24 transmission buffer. The transmission buffer starts, then MSP430 goes into LPM4 sleep mode. IRQ ping coming from the NRF24 wakes up the MSP430 from the LPM4 sleep by checking the success of the transmission.
Hello, my name is Emir Hanesim. I am responsible for second MSP. In this part of the system, we read the DHT11 temperature sensor. The working principle is briefly as follows. We configure the sensor by sending the necessary bits from MSP430. After that, we read the data from DHT11 by the help of timer. Then we encrypt data using AES standard. Then we load the transmit buffer of RF module with this encrypted data. After loading data and activating transmit mode, MSP430 goes to the LPM4 mode. IRQ pin of RF module wakes up the MSP430 from LPM4 mode. Then transmission status of RF module is checked if successful or failed. This whole process works in a while loop.
Hello, I am Seyfullah Cengiz. I am responsible for the third MSP on the system.
The third device is used as a transceiver node in the system. It listens to transmitter MSPs for encrypted sensor data. Decryption process is also done on this device. After the decryption, it sends decrypted data to fourth MSP to be displayed by an LCD module. This device works in the following way. The program starts with initializing the system. At this stage, we configure clocks, ports, and enable interrupts for the device. Then NRF module is configured to the receiver mode to listen from channel 120, which operates at a frequency of 2.52 GHz. In this step, device is put into low power mode 4 for maximum power saving. Device wakes up when a transmit request is sent from channel 120, and when receive is successful, data is taken from the NRF buffer and decrypted by using the AES algorithm. At the very beginning of the decryption process, to successfully decrypt the incoming data, the sender keys are reproduced respectively. This fact comes from the symmetric nature of the AES algorithm. After receiving and decrypting the temperature data successfully, device switches to listen from channel 100, which operates at a different frequency. After configuring an RF module to listen from channel 100, device is once again put into LPM4 for minimum power consumption. The steps described for receiving and decrypting temperature data are repeated for moisture data as well. After receiving and decrypting both sensor data, NRF module is configured to transmitter mode on channel 80. Both temperature and moisture data are loaded and sent within the payload.
My name is Alperen Berber. I am responsible from the fourth MSP on our system. In this stage, our NRF receiver receives the 32-byte payload from the transceiver MSP430 using channel 80. The payload includes sensor data in its first 2 bytes. Then, the data bytes are stored in their respective variables. First byte corresponds to temperature data and second byte corresponds to humidity data. We also print these variables on our LCD module. Our LCD module uses HT44780 library to handle its operations. This library provides configurations for 4-bit and 8-bit data pin modes. Here we used 4-bit data pin mode to have more space on our MSP430 for other possible applications. Finally, our LCD module syncs the written values by going into a timer ISR in periodic cycles. It is instructed in sources that the period of getting into ISR should be less than 10 milliseconds. We configured our MSP to go into ISR in every 5 milliseconds. It is seen that the information is continually refreshed. Now we will see the operations of our sensors.
We start with the moisture sensor. Now you see that humidity is 0. As we pour water to the soil, the moisture content of the soil increases, as you can see on the LCD screen. You can see that temperature value is steady. As we heat up the DHT11 sensor, temperature value on the LCD screen increases, as you can see on the LCD screen. Thanks for listening to us.